The Tyrannosaurus rex stands as the undisputed monarch of the dinosaur kingdom in the modern imagination. Its massive skull, bone-crushing jaws, and towering presence have dominated screens and toy shelves for decades, immortalized in films like Jurassic Park as the ultimate prehistoric predator. Yet, this cultural titan was neither the fastest nor the largest carnivore to walk the earth, merely the most sensationalized. Alongside it, the Triceratops, with its formidable frill and three-horned face, has become equally iconic, often cast as the T-Rex's armored rival in a never-ending battle of Cretaceous drama. But the Mesozoic world was far stranger than pop culture suggests. While T-Rex ruled the box office, other predators boasted adaptations just as extraordinary, some even more bizarre. Among them, a lesser-known hunter lurked in the shadows of history. Carnotaurus, the meat-eating bull, a creature built not for brute force, but for explosive speed, crowned with a pair of enigmatic horns unlike any other theropod. The public's fascination with dinosaurs often fixates on the familiar, leaving equally remarkable species overlooked. Spinosaurus, with its sail-backed silhouette and semi-aquatic habits, and Allosaurus, the apex predator of the Jurassic, each carved their own niches in ecosystems vastly different from the late Cretaceous realms of T-Rex. Yet neither possessed the peculiar blend of features that made Carnotaurus an evolutionary outlier, a predator honed for a life of relentless pursuit, its body a testament to nature's experimentation. This is not merely a story of forgotten monsters, but of a world where survival demanded more than size or strength. It demanded specialization. And in the arid badlands of ancient Patagonia, one such specialist reigned, a hunter whose legacy, buried for millennia, would challenge our understanding of predatory dinosaurs. The stage is set. The titans of pop culture have had their turn. Now it is time for the horned fury to step into the light. The fossil record teems with predators overshadowed by the cultural dominance of Tyrannosaurus rex, creatures just as formidable, yet far stranger in their adaptations. Among them, Spinosaurus and Allosaurus stand as prime examples of nature's ingenuity, each carving a niche that defies the simplistic, bigger is better narrative of prehistoric predation. Spinosaurus, the spine lizard, was a behemoth unlike any other theropod. Towering over even T-Rex in length, its elongated snout and conical teeth betrayed a semi-aquatic lifestyle, a hypothesis bolstered by 2020 findings in Nature that revealed dense bones ideal for buoyancy control. Unlike the terrestrial Carnotaurus, Spinosaurus prowled river systems, its sail-backed silhouette cutting through the water like a crocodilian nightmare. Its existence challenges the very definition of a dinosaurian predator, proving that some rulers of the Mesozoic hunted not on land, but in the murky depths. Then there was Allosaurus, the different lizard, the apex predator of the Jurassic. Older than Carnotaurus by nearly 80 million years, it was a relentless hunter, its serrated teeth and powerful neck muscles designed for slashing rather than crushing. Yet despite its success, evidenced by countless fossils from the Morrison Formation, Allosaurus lacked the bizarre specializations that would later define its Cretaceous cousins. It was a generalist, a butcher of sauropods, but not a creature honed for the kind of speed and agility that would make Carnotaurus a marvel of evolution. These forgotten hunters highlight a critical truth. The Mesozoic was not a monolithic age of reptilian giants, but a tapestry of ecosystems, each demanding unique adaptations. Spinosaurus ruled the waterways, Allosaurus dominated the floodplains, and T-Rex, much later, commanded the forests of Laramidia. But in the arid stretches of late Cretaceous Patagonia, another predator thrived, one that defied convention. Carnotaurus was neither the largest nor the most powerful, but it was arguably one of the most specialized. Built for bursts of speed, its streamlined body and muscular legs suggest a lifestyle of relentless pursuit, a stark contrast to the ambush tactics of T-Rex or the aquatic ambushes of Spinosaurus. Its horns, jutting forward like those of a bull, remain a paleontological puzzle. Were they weapons, displays, or both? The stage of prehistory was vast, and its players diverse. While pop culture fixates on the familiar, the true wonder lies in the outliers, the hunters forgotten by time, yet no less extraordinary. Among them, Carnotaurus awaits its due. The wind howled across the badlands of Argentina's La Colonia Formation, a desolate expanse of rust-colored rock and parched earth. It was here, in the summer of 1984, that paleontologist José Bonaparte led a small but determined team into the heart of Patagonia's fossil-rich terrain. The expedition was far from glamorous. Dust choked their throats, and the sun beat down relentlessly, baking the cracked earth into a mosaic of fissures. Yet beneath the surface lay secrets untouched for 70 million years. Bonaparte, a veteran of South American paleontology, had spent years unraveling the continent's prehistoric past. Unlike the lush floodplains of North America's Hell Creek Formation, La Colonia was a world of arid coastal plains where seasonal rains carved ephemeral rivers through the landscape. Towering araucaria trees dotted the horizon, their needle-like leaves whispering in the dry wind. It was a harsh environment, but one that had preserved its inhabitants in stunning detail. The team worked methodically, their picks and brushes uncovering fragments of bone weathered to the color of the earth. At first, the discoveries were modest, isolated vertebrae, a scattering of teeth. But on the third week, as the sun dipped toward the horizon, a shout echoed across the dig site. One of Bonaparte's assistants, his hands trembling, had uncovered something extraordinary. The unmistakable curve of a theropod skull, its surface pitted with deep ridges. As the team carefully excavated the find, the skull's bizarre features became impossible to ignore. Unlike the blunt, powerful jaws of Tyrannosaurus, this predator's snout was slender, almost delicate. But the most striking feature loomed above the eye sockets, a pair of thick, forward-jutting horns, their surfaces rough with vascular grooves. Bonaparte's pulse quickened. This was no ordinary theropod. The horns alone marked it as something unprecedented. No known carnivorous dinosaur bore such structures. Nearby, more bones emerged, a scattering of ribs, a femur with the telltale robustness of a sprinter's limb. But it was the arms, or rather the lack thereof, that deepened the mystery. Tiny, vestigial, they seemed almost comical in proportion to the rest of the body, mere stubs of bone compared to T-Rex's more substantial forelimbs. Night fell, but the team worked on by lantern light, their excitement overriding fatigue. Bonaparte knew they had uncovered something revolutionary. The horns, the arms, the lean build, every detail defied expectations. This was a predator built not for brute force, but for something far more specialized. As the first stars pierced the sky, the desert seemed to hold its breath. The bones, silent for eons, were ready to speak, and what they would reveal would rewrite the story of Cretaceous predation. The morning sun revealed the full extent of the find. Bonaparte's team worked with surgical precision, their brushes sweeping away sediment to expose the predator's skull in its entirety. The horns, now fully uncovered, dominated its profile. Thick, bony protrusions fused to the frontal bones, their surfaces etched with grooves that once channeled blood vessels. Unlike the curved horns of ceratopsians, these were blunt and forward-facing, resembling those of a bull more than any known theropod. Initial identification hinged on these bizarre structures. While Tyrannosaurus was instantly recognizable by its massive teeth and robust skull, Carnotaurus, as Bonaparte would later name it, bore a suite of autapomorphies that set it apart. The horns were diagnostic, a feature unseen in other carnivorous dinosaurs. Their purpose was immediately debated. Were they weapons for head-butting rivals? Ornaments for display? The team noted the absence of fractures or scars, unlike the battered frills of Triceratops, suggesting combat was rare, if it occurred at all. Then there were the arms. Excavation revealed forelimbs so reduced they bordered on vestigial, shorter even than those of T. rex, with immobile elbow joints and stubby fingers lacking claws. Bonaparte's sketches captured their absurd proportions, limbs so tiny they seemed almost detached from the rest of the muscular frame. Yet their presence wasn't accidental. Evolution had favored this reduction, trading grasping ability for streamlined speed. Comparisons to modern birds arose, kiwis with their useless wings, or flightless cormorants, hinting at a deeper evolutionary trend toward limb diminishment in specialized theropods. The spine, partially articulated, told its own story. Tall neural spines along the vertebrae anchored powerful back muscles, while the tail's rigid structure suggested a stabilizer for rapid turns. This was no ambush predator. It was built for pursuit. By midday, the team had uncovered enough to grasp the animal's proportions. Roughly 8 meters long, with a deep, barrel-chested torso and legs engineered for explosive acceleration. Bonaparte paused, wiping dust from his brow. The creature defied every expectation. Its horns, its arms, its lightweight build. None fit the mold of known apex predators. As the dig continued, whispers of Carnotaurus's ecology emerged. A single tooth, serrated and blade-like, lay near the ribs of a small ornithopod, hinting at a diet of agile prey. The La Colonia Formation, with its mosaic of arid plains and seasonal wetlands, had been a world where speed trumped brute force. By week's end, the bones were carefully crated for transport. Bonaparte knew this was more than a new species. It was a window into a forgotten predatory strategy. As the trucks rumbled toward Buenos Aires, the desert wind carried away the last traces of their work. But the horns, those strange, bull-like horns, lingered in the mind. They were the mark of a hunter unlike any other. The reconstructed skeleton of Carnotaurus stands as a testament to evolutionary ingenuity, a predator sculpted by the demands of speed and precision. Its deep, narrow skull, lined with serrated teeth, resembles a blade more than the crushing maw of Tyrannosaurus. Above the eyes, 2 thick horns jut forward like battering rams of bone, their surfaces textured with grooves that once pulsed with blood vessels. This was no generic theropod. Every inch of its anatomy whispered specialization. The skull's construction defied convention. Unlike the robust, shock-absorbing structure of T. rex, Carnotaurus's cranium was lightweight, yet reinforced along the snout, suggesting a preference for slashing rather than bone-crushing bites. A 2021 study in Cretaceous research analyzed its unique osteology, noting the fused nasal bones, an adaptation possibly reducing stress during high-speed impacts. The horns, embedded directly into the frontal bones, bore no signs of combat damage, fueling debate over their function. Were they display structures, intimidating rivals with their sheer prominence? Or did they serve as anchors for keratinous sheaths, amplifying their visual impact? Below the skull, the body was a study in muscular efficiency. The neck, thick and sinewy, connected to a barrel-shaped torso packed with power. Fossilized muscle attachment points revealed a network of tendons and ligaments capable of explosive acceleration. Unlike the ponderous bulk of T. rex, Carnotaurus was lean, a sprinter's build, with elongated metatarsals and a digitigrade stance that placed it permanently on its toes, much like modern birds. Biomechanical models from a 2016 PLOS-1 study estimated speeds upwards of 35 miles per hour, rivaling the fastest land predators today. Then there was the skin. Preserved patches of fossilized scales discovered in 1998 unveiled a hide unlike any other theropods. The skin bore rows of conical, non-overlapping osteoderms, bony nodules embedded in the flesh, interspersed with finer scales. The pattern, reminiscent of armor plating on a medieval knight, likely served multiple purposes: protection against abrasion, thermoregulation, or even visual signaling. No pigment evidence survives, but modern analogues like the knobby hide of crocodilians hint at a camouflaged predator, its hide dappled to blend into the dappled light of Patagonia's Araucaria forests. The arms, reduced to vestigial stubs, only heightened the creature's strangeness. Shorter than T-Rexes and lacking functional claws, they were evolutionary holdovers, perhaps used minimally in mating displays, as seen in some flightless birds. Their near absence underscored Carnotaurus's trade-off: forelimbs sacrificed for aerodynamic efficiency, all power redirected to the hind limbs. In life, this beast would have been a paradox, a theropod built for fleeting, furious bursts of motion, its horns glinting under the Cretaceous sun. Not the largest, nor the strongest, but a hunter honed to perfection for its niche. The cheetah of the Mesozoic, an embodiment of speed incarnate. The bones tell the story. This was a beast unlike any other. The skull of Carnotaurus is a masterpiece of evolutionary contradiction, a predator's weapon crowned with structures seemingly borrowed from an entirely different lineage. Its most striking feature, the pair of thick bull-like horns above the eyes, remains one of paleontology's most hotly debated adaptations. Were these bony protrusions tools of combat, displays of dominance, or both? The answer, buried for 70 million years, lies in the subtle clues etched into fossilized bone. Unlike the sweeping, curved horns of ceratopsians like Triceratops, Carnotaurus's horns were blunt and forward-facing, fused directly to the frontal bones of the skull. Their surfaces bore deep vascular grooves, suggesting they were once sheathed in keratin, a material that could have added length or vibrancy, much like the horns of modern bovids. Yet, despite their formidable appearance, no fossil evidence shows the telltale fractures or impact scars seen in dinosaurs known for head-to-head combat. This absence raises a critical question. If not for battle, what purpose did they serve? One prevailing theory, supported by studies of modern horned animals, posits a role in intraspecific display. Male bovids, such as bighorn sheep, use their horns not just for sparring, but as visual signals of fitness. Larger, more symmetrical horns deter rivals without the need for physical confrontation. Carnotaurus, living in a landscape of open plains and sparse vegetation, may have relied on similar visual cues. The horn's prominent placement and potential for vivid coloration could have made them irresistible to mates or intimidating to competitors, reducing the need for dangerous clashes. Yet the possibility of combat cannot be entirely dismissed. Biomechanical analyses, including 2019 Journal of Vertebrate Paleontology models, suggest the skull's reinforced structure could have withstood limited headbutting, though not the repeated trauma seen in ceratopsians. The horn's forward orientation implies a punching motion rather than locking or shoving, perhaps used in brief, ritualized contests. Modern analogues exist in the Galapagos marine iguana, where males clash heads in brief, high-impact bouts to establish hierarchy without inflicting serious injury. A third hypothesis bridges the gap. The horns may have served dual purposes. During mating seasons, they could have been flaunted in elaborate displays, their size and symmetry advertising genetic quality. In rare conflicts, they might have delivered glancing blows, their keratin sheaths absorbing shock. The lack of scarring could simply mean Carnotaurus was adept at avoiding crippling damage, a testament to the efficiency of its adaptations. The enigma deepens when compared to other horned theropods. Carnotaurus's relative Majungasaurus bore a singular dome-like crest, while Ceratosaurus sported a nasal horn more akin to a blade. This diversity suggests horns evolved independently among abelisaurids, each tailored to specific ecological or social pressures. For Carnotaurus, speed was its primary weapon. The horns, then, may have been secondary, tools for a world where seeing and being seen meant survival. As the Patagonian wind once rippled through the hides of these predators, the horns would have caught the light, a silent language of threat and allure. Whether they were wielded in battle or brandished in courtship, their legacy endures in bone, an enduring puzzle etched in Cretaceous stone. The horns remain, as they always were, an enigma, but in their mystery lies the true fascination of Carnotaurus, a predator as complex as it was swift. The skeleton of Carnotaurus tells a story of evolutionary refinement, every bone sculpted for one purpose: speed. Unlike the hulking Tyrannosaurus, built for power over agility, or the semi-aquatic Spinosaurus, adapted for buoyancy, Carnotaurus was a terrestrial sprinter, its anatomy betraying a life of explosive pursuit. From its lightweight frame to its digitigrade stance, this was a predator engineered for velocity. The key lay in its legs. The femur, though robust, was shorter than in bulkier theropods, while the elongated metatarsals and tibia formed a structure akin to a cheetah's, maximizing stride length without sacrificing power. A 2016 PLOS ONE biomechanical study estimated Carnotaurus could reach speeds upwards of 35 miles per hour, a figure rivaling the fastest modern land predators. Its digitigrade posture, walking permanently on its toes like a bird, further enhanced its acceleration, reducing ground contact time and minimizing energy loss with each stride. The spine reinforced this specialization. Tall neural arches along the vertebrae anchored massive caudofemoralis muscles, the same system that propels modern reptiles and birds in rapid bursts. The tail, stiffened by interlocking bony rods, acted as a counterbalance during sharp turns, allowing Carnotaurus to pivot mid-chase without losing momentum. This wasn't just speed. It was controlled, dynamic speed, the kind needed to outmaneuver agile prey like small ornithopods in the open plains of La Colonia. Even the ribs played a role. Unlike the barrel-chested T-Rex, Carnotaurus had a narrower thoracic cavity, reducing weight without compromising lung capacity. Its lightweight skeleton, punctuated by air-filled cavities like those in birds, suggests a predator built for short, intense sprints rather than endurance. Modern cheetahs, for all their speed, are fragile, overheating after a minute of pursuit. Carnotaurus may have faced similar constraints, its hunts brief and furious. The arms, reduced to vestigial stubs, were another trade-off. With no need for grasping prey, evolution streamlined the forelimbs into near non-existence, diverting resources to the hind limbs. This wasn't weakness, it was efficiency. Every gram of muscle not wasted on useless arms was redirected to the legs, the true instruments of predation. In life, Carnotaurus would have been a blur of motion, a predator that relied not on ambush or brute force, but on sheer terrifying speed. Its world was one of quick strikes and fleeting opportunities, where a split-second advantage meant the difference between a meal and starvation. The bones don't lie. This was a dinosaur built to run. The cheetah accelerates from 0 to 60 miles per hour in 3 seconds, a blur of spotted fur and explosive muscle. 70 million years earlier, Carnotaurus may have achieved something similar, its powerful legs propelling it across the arid plains of Patagonia in pursuit of fleet-footed prey. This was not a predator built for endurance or brute strength, but for the singular advantage of speed, a specialization that placed it in rare company among theropods. Modern pursuit hunters offer compelling parallels. Cheetahs, the fastest land animals alive today, share key adaptations with Carnotaurus: elongated limbs, a flexible spine for increased stride length, and a lightweight skeleton that prioritizes acceleration over durability. Yet cheetahs pay a price for their speed. Their fragile frames limit them to short bursts, and their small teeth require precise kills, traits that make them vulnerable to larger predators like lions. Carnotaurus likely faced similar trade-offs. Biomechanical models suggest it could sustain its top speed of 35 miles per hour for only brief intervals before overheating or exhausting its muscles, much like its modern counterpart. But unlike the cheetah, which hunts solitary and small prey, Carnotaurus inhabited a world of larger, more diverse herbivores. The La Colonia Formation teemed with potential targets. The swift Gasparinisaura, a small ornithopod built for evasion, and the juvenile titanosaurs that may have strayed too far from their herds. Speed alone wouldn't guarantee success. It had to be paired with strategy. Fossil evidence hints at a hunting style reliant on ambush sprints, where Carnotaurus used terrain features like dry riverbeds or dense thickets to close the distance before launching its attack. The predator's anatomy supports this theory. Its deep tail, stiffened by ossified tendons, acted as a rudder during high-speed turns, allowing it to match the zigzagging escape patterns of its prey. The skull, though slender, was reinforced at the snout, a possible adaptation for withstanding the impact of striking a fleeing target. Even the horns may have played a role, their forward jutting position helping to stabilize the head during sudden directional changes. Yet speed came at a cost. Carnotaurus lacked the bone-crushing bite force of Tyrannosaurus or the grappling arms of Allosaurus. Once it caught its prey, killing had to be quick, likely via precise slashes to the throat or flanks, delivered by its blade-like teeth. Missed strikes or prolonged struggles would have been energetically disastrous, forcing the predator to abandon the chase or risk injury. In the end, Carnotaurus represents evolution's gamble, a predator that traded brute force for velocity, betting everything on the ability to outrun its prey. It was a risky strategy, but one that paid off in the open landscapes of late Cretaceous Patagonia. Today, its legacy endures in the cheetah's sprint, the falcon's dive, and every creature that survives by being faster than what it hunts or what hunts it. The bones whisper of a life lived in bursts, a hunter built not for domination, but for the fleeting, furious advantage of speed. The skull of Carnotaurus presents a paradox, a predator armed with rows of serrated teeth, yet lacking the bone-crushing power of its more famous cousin, Tyrannosaurus rex. Its slender jaws, reinforced at the snout, but narrow overall, suggest a hunting strategy built on precision rather than brute force. How then did this horned hunter subdue its prey? The answer lies in the subtle interplay of anatomy and behavior, a dance of speed and surgical strikes. Bite force estimates, derived from 2018 biomechanical models published in scientific reports, place Carnotaurus at roughly 1,500 newtons, far weaker than T-Rex's staggering 35,000 newtons, but comparable to modern predators like the Komodo dragon. This was not a dinosaur that crushed bone. It was one that relied on slashing wounds to bleed out its quarry. Its teeth, curved and knife-like, were perfect for the task. Unlike the conical banana-shaped teeth of T-Rex, which were built for pulverizing, Carnotaurus's dental armament resembled the blades of a serrated steak knife, ideal for slicing through flesh with minimal resistance. The skull's construction supported this delicate but deadly approach. While the snout was reinforced to withstand lateral stresses, the jaw muscles were relatively modest, anchored to shallow attachment points. This lightweight design minimized energy expenditure during rapid bites, critical for a predator that likely struck multiple times in quick succession. Modern analogues exist in the Dilophosaurus, another slender-jawed theropod thought to have used a slash-and-retreat tactic. Carnotaurus may have employed a similar strategy, darting in to inflict deep wounds before retreating to avoid retaliation, allowing blood loss to weaken its prey over time. Prey selection further contextualizes its bite. The La Colonia Formation's ecosystem lacked the massive, armor-clad herbivores of other Cretaceous environments. Instead, Carnotaurus likely targeted smaller, agile animals like the ornithopod Gasparinizaura or juvenile titanosaurs, prey that could be outmaneuvered and worn down rather than overpowered in a single attack. Fossilized stomach contents from related abelisaurids reveal partially digested bones of small vertebrates, suggesting a diet of animals swallowed whole or torn apart with rapid, scissor-like bites. The horns may have played an unexpected role in feeding. While their primary function was likely display or limited combat, their forward position could have stabilized the skull during feeding, acting as anchors while the jaws ripped flesh. Alternatively, they might have been used to pin struggling prey, much like the foot-long claws of Therizinosaurus, though this remained speculative without direct fossil evidence. In the end, Carnotaurus's bite was a study in efficiency. It didn't need to crush, it needed to cut, and cut quickly. Speed was its greatest weapon, and its jaws were honed to exploit that advantage. A predator built not for the slow, brutal kill, but for the swift, surgical strike. The skull tells the story. This was not a monster of brute strength, but a hunter of precision, a blade in a world of hammers. Among the many peculiarities of Carnotaurus, none are as striking or as perplexing as its vestigial forelimbs. Tiny, immobile, and seemingly useless, these stunted appendages dangled from the predator's torso like evolutionary afterthoughts. Yet their very existence speaks volumes about the forces that shaped this dinosaur's lineage, offering a window into the trade-offs of specialization. The arms of Carnotaurus were shorter than those of Tyrannosaurus rex, measuring a mere 25 centimeters in length, barely enough to reach past its ribcage. Unlike the T-Rex's more robust limbs, which retained some functionality for grasping or slashing, Carnotaurus's forelimbs were rigid, their four-fingered hands fused into immobile stubs devoid of claws. The elbow joints lacked the flexibility seen in other theropods, rendering them incapable of meaningful motion. To call them arms feels almost charitable. They were little more than bony protrusions, vestiges of a more anatomically versatile past. This extreme reduction wasn't accidental. Evolution favors economy, and in Carnotaurus, every ounce of energy was redirected toward speed. Theropod forelimbs had been shrinking since the Jurassic, a trend seen in lineages like the tyrannosaurs and abelisaurids. But Carnotaurus took this to an extreme, sacrificing grasping ability entirely for aerodynamic efficiency. Modern flightless birds, like kiwis or cassowaries, exhibit similar vestigial wings, structures too small for flight, but occasionally repurposed for balance or display. Similarly, Carnotaurus's arms may have served some minor function, perhaps as visual signals during mating rituals, their small size offset by exaggerated movements or vibrant scales. The question remains, why retain them at all? Vestigial structures often persist when their loss offers no selective advantage. In Carnotaurus, the arm's minimal mass likely imposed no significant metabolic cost, allowing them to linger even as their utility faded. Alternatively, they may have played a role in embryonic development, their genetic blueprint too deeply embedded to discard. Some paleontologists speculate they anchored muscles for shoulder stabilization during high-speed runs, though fossil evidence for this is scant. Comparisons to other theropods highlight the uniqueness of Carnotaurus's condition. T. rex, despite its famously short arms, retained powerful musculature and functional claws, possibly for pinning prey. Even Mononychus, a theropod with single-clawed, wing-like arms, likely used them for digging. But Carnotaurus's limbs defy easy explanation. Their near-total atrophy suggests a predator so specialized for speed that even the slightest hindrance, be it weight or drag, was evolutionarily untenable. The arms of Carnotaurus are a testament to nature's pragmatism. In a world where survival hinged on velocity, they were deemed expendable, relics of an older, slower way of life. Yet their persistence, however diminished, whispers of the complex interplay between form and function, a reminder that even the most bizarre adaptations are never truly useless. They were the arms that weren't, and in their absence, Carnotaurus became something extraordinary. The fossilized skin impressions of Carnotaurus are a paleontological treasure, rare, exquisitely preserved windows into the texture and appearance of a predator lost to time. Discovered in 1998, decades after the initial excavation of its bones, these impressions reveal a hide unlike that of any other known theropod, a mosaic of bony nodules and fine scales, forming a surface both rugged and strangely ornate. The skin was armored with rows of conical osteoderms, bony deposits embedded in the flesh, each measuring up to 5 centimeters in diameter. These protrusions were not arranged haphazardly, but formed distinct patterns, clustering along the flanks and spine like the segmented plates of a medieval brigandine. Between them, smaller, pebble-like scales filled the gaps, creating a flexible yet protective surface. The overall effect, as noted in a 2021 Cretaceous research study, would have resembled the knobby hide of modern crocodilians, though with a more pronounced three-dimensional texture. Functionally, this armor likely served multiple purposes. The osteoderms may have provided defense against abrasion from dense vegetation, or the occasional retaliatory strike from prey. Their placement along the spine and flanks, areas most vulnerable to slashing attacks, suggests a degree of passive protection. Yet their prominence also hints at a possible role in thermoregulation or even display. In extant reptiles like the Gila monster, osteoderms aid in heat absorption, their dark surfaces soaking up sunlight. For Carnotaurus patrolling the sun-baked plains of Patagonia, such an adaptation would have been invaluable. The finer scales between the osteoderms add another layer of intrigue. Their tight, non-overlapping arrangement implies a smooth but durable surface, reducing drag during high-speed pursuits. Modern analogues exist in the streamlined scales of fast-moving lizards like the collared iguana, which minimize air resistance during sprints. But the most tantalizing question remains: what color was Carnotaurus? No pigment cells have been preserved in its fossils, leaving its patterning open to speculation. Some researchers propose camouflage, dappled greens and browns to blend into the Araucaria forests and scrublands of La Colonia. Others suggest bold contrasts, with the osteoderms forming conspicuous stripes or spots to intimidate rivals or attract mates. Without direct evidence, these theories remain provisional, grounded only in comparisons to living reptiles and the ecological demands of its habitat. One thing is certain: Carnotaurus was no dull, monochromatic brute. Its skin, textured and possibly vibrant, would have shimmered under the Cretaceous sun, a living tapestry of form and function, as much a weapon as its horns or teeth. The impressions endure, a silent testament to a predator clad in evolutionary ingenuity. In life, this hide was its armor, its regulator, perhaps even its canvas. Today, it is a fossilized whisper of the flesh that once moved with speed and purpose. The La Colonia Formation stretched across late Cretaceous Patagonia like a vast, sun-scorched stage, a land of extremes where towering Araucaria conifers cast jagged shadows over brackish wetlands and wind-rippled plains. This was Carnotaurus's domain, a mosaic of ecosystems that shaped its evolution into one of history's most specialized predators. Unlike the swampy floodplains of Hell Creek or the river deltas of North Africa, La Colonia was a world of contrasts. Seasonal rains transformed arid basins into temporary lagoons, their waters teeming with lungfish and turtles, while drought could parch the land into cracked clay within weeks. The flora reflected this volatility. Groves of Araucaria, their needle-like leaves resistant to desiccation, clustered along elevated ridges, while ferns and horsetails thrived in the low-lying wetlands. For a predator built for speed, this patchwork of open terrain and dense thickets offered both opportunity and challenge. The coastal influence was undeniable. Fossilized mollusk shells and marine sediments confirm proximity to the Atlantic's ancient precursor, suggesting Carnotaurus may have patrolled shorelines where tidal flats bled into freshwater marshes. Here, the predator could exploit multiple food sources, schools of fish stranded in shrinking pools, or small ornithopods like Gasparinisaura venturing to drink. The environment demanded versatility. A hunter capable of sprinting across salt-crusted mudflats one moment, then weaving through dense stands of conifers the next. Wind shaped the landscape as much as water. Fine-grained sandstone layers, etched with fossilized ripple marks, speak of relentless gusts sculpting dunes along the basin's edges. For Carnotaurus, this meant hunting in a world of shifting visibility, where dust clouds could cloak an approach or betray movement to alert prey. Its textured hide, studded with osteoderms, may have doubled as camouflage amid the gnarled bark of Araucaria trunks or the dappled light of reed beds. Temperature extremes further honed its adaptations. Daytime highs likely exceeded 40 degrees Celsius, 104 degrees Fahrenheit, favoring a predator capable of explosive bursts over prolonged chases. At night, however, the desert cold would have sapped heat from even a muscular theropod, a constraint that may explain Carnotaurus's potential for rapid thermoregulation, its osteoderm-rich skin absorbing sunlight by day and retaining warmth after dark. This was no static backdrop, but a dynamic arena where every adaptation, from the horns to the vestigial arms, served a purpose. The world of Carnotaurus was one of fleeting opportunities and relentless pressure, a crucible that forged not just a hunter, but a masterpiece of evolutionary precision. The stage was set. The players awaited. And in the shadows of the Araucaria, a horned silhouette moved, a blur of speed incarnate. The late Cretaceous ecosystem of La Colonia was not defined by Carnotaurus alone. Beneath the towering Araucaria trees and along the fringes of seasonal lagoons, a diverse cast of creatures thrived, each playing a role in the delicate balance of predator and prey. Turtles the size of car tires plodded through shallow waters, their shells scarred from narrow escapes. Snakes, ancestors of modern boas, slithered through the undergrowth, hunting small mammals and lizards that darted between the ferns. These were the supporting actors in Carnotaurus's world, a living tapestry of survival and adaptation. Among the most common herbivores were the small ornithopods like Gasparinisaura, swift bipedal dinosaurs built for evasion. Their fossils, often found in groups, suggest they moved in herds, a defensive strategy against predators. For Carnotaurus, these agile plant-eaters would have been primary targets, their speed necessitating the predator's explosive bursts of acceleration. Fossilized trackways from similar environments show parallel paths of small, three-toed prints suddenly interrupted by deeper, longer strides, a snapshot of pursuit frozen in stone. The wetlands harbored larger prey as well. Juvenile titanosaurs, their bones less ossified and more easily crushed, occasionally strayed from their herds. While an adult Saltosaurus would have been invulnerable to Carnotaurus, a subadult, weighing a few hundred kilograms, could have been vulnerable if isolated. The predator's slender jaws and slashing teeth were ill-suited for tackling fully grown sauropods, but a young or injured individual might have been within its capabilities. The smallest inhabitants of La Colonia, early mammals like Regatherium, were likely insignificant in Carnotaurus's diet. No larger than a modern badger, these creatures would have been mere morsels for a predator of its size. Instead, they scurried through the underbrush, their fossilized teeth hinting at diets of insects and seeds. For them, Carnotaurus was less a direct threat than a looming shadow, a reminder of the dangers that ruled the daylight hours. The waterways, too, teemed with life. Freshwater turtles like Prochelidella based on half-submerged logs, while lungfish burrowed into the mud during dry spells, their fossilized toothplates evidence of a resilient lineage. Crocodilomorphs, smaller and more agile than their modern descendants, patrolled the shallows, snapping at fish and unwary small dinosaurs. These semi-aquatic hunters occupied a niche Carnotaurus rarely encroached upon, their domains separated by necessity and adaptation. For Carnotaurus, this ecosystem shaped every aspect of its existence. The open plains demanded speed, the dense thickets required maneuverability, and the ever-present competition for resources honed its predatory efficiency. It was a world of constant negotiation between predator and prey, between survival and extinction. And in the heart of this ancient wilderness, Carnotaurus reigned, a horned spectre of speed and precision, its legacy etched not just in bone, but in the very fabric of its lost world. In the harsh, sun-baked expanse of late Cretaceous Patagonia, Carnotaurus stood unchallenged, a predator perfectly adapted to dominate its world. Unlike the sprawling ecosystems of North America or Asia, where multiple large theropods competed for supremacy, the La Colonia Formation offered no evidence of rival carnivores matching its size or specialization. This was a kingdom of one, where speed and precision reigned supreme. The absence of competing apex predators in the fossil record suggests Carnotaurus occupied a unique niche. Where Tyrannosaurus shared its realm with smaller but formidable hunters like Dakotaraptor, and Allosaurus coexisted with Ceratosaurus, Carnotaurus faced no such rivals. Its primary competition likely came from its own kind, interspecies conflicts over territory or mates, resolved through displays or brief ritualized clashes. The horns, though not definitively linked to combat, would have served as potent visual deterrents, their prominence signaling dominance without the need for physical confrontation. Prey selection further cemented its status. The swift ornithopod Gasparinisaura was an ideal target, its agility necessitating Carnotaurus's explosive bursts of speed. Juvenile titanosaurs, though rare in the fossil record, may have been vulnerable when separated from their herds. Unlike the bone-crushing T-Rex, which could tackle armored herbivores like Triceratops, Carnotaurus specialized in fleet-footed prey, its slender jaws and serrated teeth optimized for quick, slashing strikes. This narrow focus reduced direct competition with other carnivores, allowing it to exploit a hunting strategy few could match. Scavenging, too, played a role. Like most predators, Carnotaurus would not have passed up an easy meal. The arid environment of La Colonia meant carcasses desiccated quickly, preserving meat for longer periods, a boon for a predator built for short, intense bursts of activity rather than prolonged searches. Fossilized trackways hint at scavenging behavior, with theropod prints circling the remains of titanosaurs, though whether these were left by Carnotaurus or smaller opportunists remains uncertain. The ecosystem itself shaped its dominance. The open plains and sparse vegetation favored a pursuit predator, while the lack of larger, bulkier carnivores suggested an environment where speed trumped brute force. Even the seasonal wetlands, with their labyrinth of channels and reed beds, would have been navigable for a lean, agile hunter, its osteoderm-studded hide offering protection against abrasive foliage. Yet dominance came with vulnerabilities. Carnotaurus's specialization for speed left it ill-equipped to handle drastic ecological shifts. A change in prey availability or the arrival of a competing predator could have destabilized its reign, a fragility echoed in modern cheetahs, which thrive only in the absence of larger carnivores like lions. In the end, Carnotaurus was the undisputed apex of its world, a predator honed to perfection for a specific time and place. Its bones tell a story of unrivaled adaptation, of a hunter that needed no rivals because it had mastered its domain. The food chain bent to its will, and at its peak, unchallenged, the horned fury reigned. The horns of Carnotaurus stand as silent sentinels to a world of conflict and courtship, a world where dominance was asserted not just through brute force, but through display, intimidation, and ritual. Unlike the fractured frills of ceratopsians or the impact scars of battling triceratops, Carnotaurus's horns bear no definitive evidence of combat. Yet their sheer prominence suggests they played a crucial role in the social dynamics of this predator, whether as weapons, signals, or both. Modern horned lizards offer compelling parallels. Male chameleons, for instance, engage in ritualized battles where they lock horns, pushing and shoving until one concedes, rarely inflicting serious injury. The horns of Carnotaurus, though far more robust, may have served a similar purpose. Their forward-facing orientation suggests they were ill-suited for locking or prolonged shoving matches, but their reinforced bases could have withstood brief, high-impact clashes. Biomechanical models indicate that the skull's structure could absorb limited force, supporting the idea of quick, decisive contests rather than prolonged brawls. The absence of horn fractures in fossils, however, complicates this theory. In ceratopsians like Triceratops, healed injuries on frills and horns provide clear evidence of combat. Carnotaurus's horns, by contrast, show no such damage. This could imply that fights were rare, or that the horns were sheathed in keratin, a material that might have absorbed blows without leaving marks on the underlying bone. Alternatively, their primary function may have been visual rather than physical, their size and symmetry broadcasting fitness to rivals and potential mates. The horn's vascular grooves hint at another possibility. They may have been flush with blood during displays, flushing with color to amplify their visual impact. Modern birds, theropods' living descendants, use similar tactics. Think of the wattles of a rooster or the inflatable throat sacs of frigate birds. In the open landscapes of La Colonia, where visibility was high, such displays could have been critical for establishing territory or attracting mates without the risks of physical confrontation. The environment itself may have shaped these behaviors. The arid plains and sparse vegetation of Patagonia offered little cover for ambush predators, making visual signaling an efficient means of communication. A raised head, horns catching the sunlight, could have been enough to deter a rival or impress a potential partner. The horn's prominence would have made them impossible to ignore, a constant, unspoken language of threat and allure. Yet the question remains, did Carnotaurus fight? The answer, like so much in paleontology, lies in the gaps between evidence and inference. Without fossilized proof of combat, The horn's role in intraspecies conflict remains speculative. What is certain is that they were not passive ornaments. Whether wielded in battle or brandished in display, they were instruments of survival, tools for navigating a world where dominance meant everything. The horns endure, their purpose still debated. But in their mystery lies the essence of Carnotaurus, a predator as enigmatic as it was formidable, its social world written in bone and lost to time. The horns of Carnotaurus may have been its most striking feature, but their true purpose extended beyond mere ornamentation. In the harsh, sunlit plains of late Cretaceous Patagonia, where visibility was high and cover sparse, visual displays would have been critical for communication, particularly during mating seasons. Like modern birds with their elaborate crests and vibrant plumage, Carnotaurus may have relied on its horns as signals of fitness, dominance, and reproductive readiness. Cassowaries provide a compelling modern analogue. These flightless birds, descendants of theropods like Carnotaurus, sport bony casques atop their heads, structures once thought to be weapons, but now understood as visual and acoustic displays. The casques amplify low-frequency calls, resonating through dense forests to attract mates or warn rivals. Similarly, Carnotaurus's horns could have served as both visual and auditory signals. Their vascular grooves suggest they were richly supplied with blood, potentially allowing for color changes during displays, flushing deep red or vibrant hues to emphasize health and vigor. Vocalizations, though speculative, may have played a role as well. The deep, narrow skull of Carnotaurus could have housed resonating chambers capable of producing low-frequency sounds, much like the infrasound used by modern elephants to communicate over long distances. In the open landscapes of La Colonia, such calls would have carried far, broadcasting territory claims or mating availability. Fossilized hyoid bones, the structures that support vocal organs, have yet to be found in Carnotaurus, but their relatives, like Majungasaurus, possessed robust hyoids, hinting at the potential for complex vocalizations. Mating rituals themselves remain shrouded in mystery, but comparative anatomy offers clues. Many modern reptiles engage in elaborate courtship behaviors. Male iguanas bob their heads to assert dominance, while frilled lizards extend their neck flaps in dramatic displays. Carnotaurus, with its muscular neck and prominent horns, may have performed similar rituals. A raised head, horns tilted to catch the light, could have been an irresistible signal to potential mates, while aggressive posturing, lowering the skull, puffing the body, might have deterred rivals without physical confrontation. The horn's orientation also suggests a possible tactile function during courtship. Unlike the backward-curving horns of ceratopsians, Carnotaurus's forward-facing protrusions could have been used to gently nudge or guide a mate, much like the snout-touching behaviors seen in some birds. This delicate interaction would have contrasted sharply with the predator's otherwise ferocious demeanor, a reminder that even the most fearsome hunters had moments of vulnerability. Yet the fossil record remains silent on these intimate details. No nests, eggs, or juvenile specimens of Carnotaurus have been discovered, leaving its reproductive biology open to speculation. Did it guard its young, like some modern crocodilians, or abandon its offspring to fend for themselves, as many reptiles do today? The answers may lie buried in the badlands of Patagonia, waiting for another fortuitous discovery. What is certain is that Carnotaurus lived in a world where survival depended on more than speed and strength. It demanded communication, ritual, and the subtle dance of courtship. Its horns, whether for display, combat, or both, were instruments in this ancient performance, a language of bone and blood long since faded into stone. The rituals are lost, but the horns remain, silent witnesses to a time when dominance and desire were written in the angle of a skull, the flare of a crest, the tilt of a horn toward the Cretaceous sun. The reign of Carnotaurus marked the twilight of an extraordinary lineage. As one of the last surviving abelisaurids, this horned predator stood at the end of a long evolutionary road, a road that had seen its kind dominate the southern continents for millions of years. While tyrannosaurs ruled Laurasia, the abelisaurids, including Carnotaurus, thrived in the isolated land masses of Gondwana, their adaptations honed by the unique pressures of their environment. By the late Cretaceous, the abelisaurids had reached their peak diversity, with species like Majungasaurus in Madagascar and Rugops in Africa. Yet Carnotaurus was among the final members of this once widespread family. Its specialized anatomy, the vestigial arms, the streamlined body, the distinctive horns, represented the culmination of a lineage that had experimented with various forms of predation. Unlike the more generalized abelisaurids of earlier epochs, Carnotaurus was a hyper-specialized sprinter, its every feature fine-tuned for speed and agility. This specialization may have been both its strength and its downfall. The world of the late Cretaceous was changing. The breakup of Gondwana had left South America increasingly isolated, its ecosystems growing more insular. The rise of new herbivores, such as the armored titanosaurs, presented challenges that Carnotaurus's slender jaws and lightweight build were ill-equipped to handle. While it excelled at hunting smaller, faster prey, shifts in vegetation and climate could have disrupted the delicate balance of its ecosystem, leaving it vulnerable. Unlike Tyrannosaurus rex, which perished in the cataclysm of the KPG extinction, Carnotaurus likely vanished earlier, its lineage fading as environmental pressures mounted. Fossil evidence suggests that abelisaurids were already in decline by the end of the Cretaceous, their niches gradually overtaken by other predators or rendered obsolete by changing conditions. The horns that had once made Carnotaurus unique became relics of a bygone era, their purpose lost in the shifting sands of time. Yet its legacy endures. The discovery of Carnotaurus reshaped our understanding of theropod diversity, proving that speed and precision could rival brute force in the hierarchy of predation. Its bizarre anatomy, the horns, the arms, the textured skin, continues to inspire debate and fascination, a testament to nature's boundless creativity. In the end, Carnotaurus was not just a predator. It was the last gasp of a dynasty, a final flourish of evolutionary innovation before the curtain fell on its world. The bones remain, whispering of a time when the horned fury ruled the plains of Patagonia, a fleeting, furious chapter in the story of life on Earth. For decades after its discovery, Carnotaurus remained a footnote in paleontology, a bizarre oddity overshadowed by the cultural titans like Tyrannosaurus rex. Yet as science peeled back the layers of its anatomy and ecology, this horned predator emerged as one of the most specialized theropods ever to walk the Earth. Its legacy is twofold: a revolution in our understanding of predatory dinosaurs, and a slow but undeniable infiltration of popular culture. Bonaparte's 1985 description of Carnotaurus shattered preconceptions about theropod diversity. Here was a predator that defied the T-Rex archetype, built not for crushing power, but for blistering speed, its body streamlined to perfection. The discovery underscored South America's role as a cradle of evolutionary innovation, where isolation had birthed creatures unlike anything in the northern continents. Subsequent finds of related abelisaurids, Orcosaurus, Equixnatosaurus, revealed a whole family of predators thriving in Gondwana while tyrannosaurs dominated elsewhere. The scientific impact extended beyond classification. Carnotaurus became a case study in evolutionary trade-offs. Its vestigial arms, once dismissed as useless, sparked debates about theropod limb reduction that persist today. The 1998 discovery of its skin impressions, with their mosaic of osteoderms and scales, offered rare insights into dinosaurian integument, influencing reconstructions of other species. Even its horns, still enigmatic, forced paleontologists to reconsider the role of display structures in carnivorous dinosaurs, a trait once thought exclusive to herbivores. Pop culture, however, was slower to embrace Carnotaurus. While Jurassic Park cemented T-Rex and Velociraptor as icons, Carnotaurus languished in obscurity until the 2000 Disney film Dinosaur featured a pair as antagonists, albeit oversized and inaccurately depicted. The Jurassic World franchise later amplified its fame, though again took liberties, exaggerating its size and aggression to fit the monster movie mold. These portrayals, while flawed, introduced the dinosaur to millions, ensuring its place in the public imagination. Beyond entertainment, Carnotaurus endures as a symbol of nature's ingenuity, a reminder that evolution crafts not just brute force, but precision and specialization. Its bones, once buried in Patagonian dust, now speak to a world where speed ruled, where horns gleamed under the Cretaceous sun, and where a predator unlike any other carved its name into history. The legacy lives on. In museums, in films, in the ongoing dig sites of Argentina, Carnotaurus stands as a testament to the strangeness and splendor of the Mesozoic, a horned fury finally claiming its due. The world of Carnotaurus may have vanished 70 million years ago, but its ghost lingers in the ecosystems of today. The principles that shaped its existence, speed, specialization, and the delicate balance of predator and prey, echo through the lives of modern apex predators. From the cheetah's explosive sprints to the solitary dominance of tigers, nature continues to refine the same strategies that once made Carnotaurus the terror of Patagonia. The cheetah, Earth's fastest land animal, mirrors Carnotaurus in its reliance on acceleration over endurance. Both predators evolved lightweight skeletons, elongated limbs, and muscular tails for stability during high-speed pursuits. Yet this specialization comes at a cost. Cheetahs, like Carnotaurus, are vulnerable to larger carnivores. Lions and hyenas steal their kills much as tyrannosaurs might have bullied smaller theropods. The parallel underscores a universal truth. Speed is a powerful weapon, but it demands perfect conditions to succeed. Big cats offer another lens into Carnotaurus's world. Tigers, solitary and territorial, may have shared hunting strategies with the horned predator. Both relied on ambush and short bursts of speed, targeting prey that could be overpowered quickly. The tiger's striped coat, blending into dappled forest light, finds its Cretaceous counterpart in Carnotaurus's osteoderm-studded hide, textured for camouflage amid Araucaria shadows. Even their territorial behaviors align. Modern cats mark domains with scent, while Carnotaurus may have used visual displays or vocalizations to ward off rivals. Yet the most striking parallel lies in the fragility of apex predators. Just as Carnotaurus disappeared amid shifting ecosystems, modern predators face extinction due to habitat loss and human encroachment. The same forces that doomed the dinosaurs, climate change, ecological disruption, now threaten species like the Amur leopard and African wild dog. Conservationists today grapple with questions Carnotaurus never faced: how to preserve hunters in a world where their domains shrink by the day. The lesson of Carnotaurus is one of adaptation and vulnerability. It thrived in a world that rewarded specialization, yet its very perfection made it susceptible to change. Today's predators walk the same knife edge, their survival hinging on balance, between speed and strength, between dominance and adaptability. The echoes are unmistakable. In the sprint of a cheetah, the glare of a tiger, the desperate struggle of endangered hunters, Carnotaurus whispers across the ages. Its bones are more than fossils. They are a mirror reflecting the timeless dance of predator and prey. The world changes, the rules endure. The bones of Carnotaurus lie silent now, frozen in stone, a ghostly imprint of a world long vanished. Yet in their stillness, they speak volumes. This was no ordinary predator, no mere footnote in the Mesozoic's sprawling saga. It was a masterpiece of evolutionary specialization, a creature sculpted by the relentless pressures of its time. The La Colonia Formation, with its arid plains and seasonal wetlands, shaped Carnotaurus into a hunter unlike any other. Its body, streamlined for bursts of speed, its horns jutting forward like the weapons of some ancient gladiator, its hide studded with bony armor, every detail whispered of a life lived on the edge of survival. Here was a predator that did not dominate through brute force, but through precision, agility, and the ruthless efficiency of its adaptations. Modern science has peeled back the layers of its existence, yet mysteries remain. The horns, still debated, stand as symbols of the enigma Carnotaurus embodies. Were they weapons, displays, a language of bone and blood lost to time? The fossils offer no definitive answers, only tantalizing clues. Perhaps that is fitting. Some truths are meant to linger just beyond our grasp, reminders that the past will always hold its secrets close. In museums, reconstructed skeletons strike poses of frozen fury, their hollow eye sockets staring into a world they will never see again. Visitors circle them, marveling at the horns, the tiny arms, the sheer strangeness of this Cretaceous anomaly. Children press their hands to glass displays, their imaginations igniting at the thought of such a creature thundering across prehistoric plains. Scientists lean in, scrutinizing the fine grooves of osteoderms or the angle of a femur, piecing together the puzzle of its life. Carnotaurus was not the largest, nor the strongest, nor the most famous of dinosaurs. But it was, in its way, perfect. A predator honed to excel in its niche, a testament to nature's ability to craft brilliance in the most unexpected forms. Its legacy endures not just in fossils, but in the questions it forces us to ask, the boundaries it pushes in our understanding of theropod diversity. The wind no longer stirs the dust of Patagonia's badlands around its footsteps. The sun no longer glints off its hide as it streaks after prey. But in the quiet halls of science and the vaults of human curiosity, Carnotaurus lives on, a horned fury remembered, a whisper from a lost world. The bones have spoken, and their story, though fragmented, is one of wonder.